This only works if people can hear me. You can work on your stuff as long as you're not distracting other people. So now's the time. If you are sitting next to friends, sitting next to people you want to work with, ignoring me, you cannot be talking over me, aka you cannot be talking at all. You may be whispering, but whispering and talking are two very different things. Whispering, I can't hear any tone. Talking, I can hear tone. Like I am whispering. No, you're not. This is whispering. This is not. Got it? Got it. All right, number 5. I don't remember who asked it, but that was the first question on chapter 2. Says, divide using, that's not going to help. Long division. Now, some of you are like, oh, well, no stress. I don't need to, and I'll synthetic. But this one, it's illegal to use synthetic. How come? Synthetic only works if it's an x to a 1 power. It could be 3x, 2x, but you can't do an x squared with synthetic. Good. So, whatever's on top goes in the box. I have to keep placeholders for every possible x term in the progression from x cubed to a constant, hence why I put the 0. But I only have to do that on the inside where I'm keeping everything lined up, not the outside. Long division asks the question, how many times does the biggest term on 1 go into the biggest term, meaning the highest powered term, the highest degree term? How many times does it go into it? Or what times just this outer would give me this outer? 3x is the answer. What a lot of people forget in long division is when you go to multiply, you have to multiply by both terms, or however many terms are out here. You have to distribute. So 3x times x squared is 3x cubed. 3x times 1 is 3x. But why would I not write it in this column? Yeah, it needs to be like terms. Whenever we're doing long division, we have to subtract. But I'm going to highlight this subtraction because what's really easy to forget, to distribute that to both. So 3x cubed minus 3x cubed, perfect. 0x squared plus 0 is just 0. 4x minus 3x is 1x. Now usually we'd ask ourselves, how many times does this multiply to be that? But we would have to divide, not multiply. Well, multiply by a reciprocal. Since this is smaller, we automatically call this a, careful, getting a little too loud, remainder. Since it's a smaller degree term, it's a remainder. And remainders we can write as x minus 1 over x squared. Whatever the remainder is over the original denominator. And this would be the answer to my long division. Tony, what's up, bud? Didn't you have a question? Oh, you were just putting in your headphone. I thought I saw your hand go up. Okay. Kathleen. Okay. Before I go to number 7, if you're listening as far as final hints, here's a good one. Weren't we just talking about asymptotes a second ago? And a long answer where you have to identify all sorts of different things? Question. Which asymptote would this long division help me find? No, careful. Horizontal is degree test. Top wins. No horizontal asymptote. Vertical? No, because that when you look in the bottom, find the zeros that don't factor out, that aren't shared on top. Who's the other asymptote? The slanty one, otherwise known as the oblique one. You might want to make a quick note to yourself. If you are asked for an oblique or a slant asymptote, or if you're asked for all the asymptotes, a slant asymptote, this math would help you find. Because the slant asymptote would be at y equals 3x. What do you notice is there, and what do you notice is not there? The 3x is there from the long division, but what did not get included? The remainder. Slant asymptotes say, do the long division, but only steal the whole answer, ignore the remainder. Remember, slant asymptotes are those guys that you would graph the line, but when you graph with an intercept of 0, up 3, over 1, you make it dotted. And somehow, your function is going to be getting closer and closer and closer to this asymptote. Usually you have something like this with a vertical asymptote. This one you don't because of the squared. There's no vertical asymptotes, but usually you have like little curves that are fit in and going towards the slanty one and the vertical one. This one's a little weird in that there are no vertical asymptotes. This would be a pretty bad example for me to use on a long answer because you'd have to write none for a lot of stuff. There definitely are still intercepts, but anyway, just a little random. Long division, while we're at it, doesn't just answer a division problem. It can also answer a slant asymptote problem. Okay, with that, number 7. Use synthetic division to show that. Ah ha ha. Hey guys, what's another good long answer on the final? A big old nasty polynomial that I say to factor completely. Guess how many of you, and not as many in honors as in regular, but got to that question or those questions, there was a multiple choice and a long answer on that test. Just decided to skip them or do very minimal work on them. Oh dear. Being able to factor a really big polynomial was the grand finale of chapter 2. But the nice thing is, they gave us a hint on this one. They said, hey, by the way, 5/2 is a 0. Oh, cool. So therefore, right away, I can throw 5/2, which gives me automatically a factor. I know a factor already. They said x equals 5/2 is a 0. I'm like, sweet. That means he comes from a factor. But I still have, well, wait, if this is a cubic, how many different factors can I have up to? 3. Yeah, an x for each one, because x times x times x is x cubed. I can have up to 3, so I'm missing 2. But hopefully this synthetic will help me out. Remember synthetic, we take the coefficients. And synthetic, what's the very first step every time? Take down. Now some of you might not like this, but 5/2 times 2 technically over 1. 5/2 times 2 over 1, the 2's reduced and you're left with 5. Well, this isn't bad. -5 and 5 is 0. Anything times 0 is 0. Bring it down, -6. Oh. Yeah. You can say 5 times -6 is -30 divided by 2. Is -15. You can also reduce the 2 and the 6 because that would be on top. And the 2 would be on bottom to 3/1. 3 times 5 is 15. Either way, I end up with a remainder of 0. And shouldn't you have known that was going to happen already? Because of the remainder theorem, if the remainder is 0, I know that that factor goes in perfectly. Or I should say that 0 goes in perfectly. What's left? It's an x squared because I have constant x term, x squared term. 2x squared, no x terms, and -6. How do I keep factoring? Well, it's the quadratic, though. Hopefully we wouldn't have to do synthetic. What should you, over here, a quick reminder of factoring, what should you always try to do first when factoring? Don't you see a 2 in both? You could simplify your life just a little bit and pull out a 2. But even when you pull out a 2, you still have what we would call a difference of squares. Do you guys remember every time what we do with differences of squares? Even if you pull out a 2, you still have x squared minus, but it's just not a pretty number. But we aren't bound to pretty numbers, are we? We did imaginaries. Can't we do what we always do with difference of squares and do x plus the square root even if you don't know it, and x minus the square root even if you don't know it? Kathleen, there's our full, what we would call factorization under irrationals, because that weird root 3 is how you would technically describe it. But then they also ask for the zeros. But at this point, it's not too bad. We already knew 1, and we just found the other 2. Wait a minute, this guy. What about O? Can 2 ever equal 0? No. So we don't think about him when looking for zeros. We only look at the terms that have x's. So factorization, 0 is done. Now number 8 has us going into imaginary numbers. P.S. Did I assign number 9? You might want to look at number 9, just thinking about the final. Because isn't he a nasty simplification of an imaginary? I gave you the basics, but maybe the not so basics are good too. What would you multiply him by, top and bottom? 2 minus I. It's weird. It's not normal. By the conjugate. Okay, but we're looking at number 8. Letter A is a little tricky because I only see one term unless I look a little deeper and say, hold on. I'm going to distribute the negative because I'm a good math student and don't kill seals. But why am I also going to write 5I instead of square root of negative 25? Square root of 25 is 5. Well, the negative just came from the distributing of the minus. Square root of negative 1. The 25 became a 5. Square root of negative 1 became the I. Now I can go ahead and combine like terms, and proper form of an imaginary number is the real part first and the imaginary part second. A plus BI. Yeah.
So the form that you want A.
Yeah, but on like a multiple choice question, which is what this would probably be, or something similar with imaginary numbers, I'm not going to have one choice have it written right and one choice have it written wrong. So if for any reason it's flipped, there must be something wrong also. Does that make sense? Okay. For letter B, are we going to kill puppies? I'm just kidding. I mean, this isn't really a puppy problem, but what are we going to do to solve? Foil. We're going to FOIL, but when else are we going to FOIL? I know, just random, but for the final, if you see this, how are you going to do it? X plus 2 times x plus 2 is not a shortcut problem. Well, some of you do have a shortcut, but not as short as most of you would make it. Remember, you have to FOIL anytime you have two binomials, which this has two binomials, which is why we have x squared plus 4x plus 4. You have to FOIL. Now, this one was more obvious in a FOILing problem because there were lots of terms. Some of you might notice a difference of squares, but I'm just going to go ahead and FOIL the whole thing out. First, outer. Now, here's what's a little weird. Some of you might not realize the square root is only over the 3, not the I. The I is a square root of a negative 1. He's already been dealt with. I would have written it 2I root 3, but they're trying to show you coefficient I, like the form says you should do. I know, it's weird, but if you look real close, the square root stops. They don't put the little tail on like I do to help, but their square root does stop over the 3. And the last one would be minus square root of 9I squared. Root 3 times 3 is root 9, which is just 3. These two cancel out, so I have 4. And here's something that might be good to highlight, mark down. What's I squared simplify to be? Good. Because I squared is the square root of negative 1 squared, which is just, so your final answer is 7. Didn't hear any other questions from chapter 2, but I'm available if there are any more. Robbie? 16 and 17. Hey, do you guys look at 14 through 16 in the directions? Identify intercepts, asymptotes, sketch. What does that kind of sound like? A long answer I just kind of hinted at a second ago. So I added in things like symmetry and domain. Okay. 16 is what we call a rational function. It's a ratio. A rational function, it's a ratio. Rational functions, Robbie, I'm going to identify, and maybe you guys want to pay attention, maybe you don't. I'm going to identify everything I think that you should identify in analyzing the function. And if I think you should, and I'm the one making the test, it might be good to look and pay attention. Domain, x can't equal 1, right? But what kind of problem is that? Is that a removable discontinuity or a non-removable? Is that a vertical asymptote, non-removable, or a whole, removable? There are two ways to figure that out. You could say, hey, what's going on at 1? If I plug in, don't I get 3 over 0? Do you guys remember what kind of 0 has a number on top? Is that a whole or a vertical asymptote? It's a vertical asymptote. Another way of looking at it is, can I reduce out the x minus 1 factor? No. Non-removable. This isn't just a discontinuity, it's a vertical asymptote. Is there a horizontal asymptote? Nope. Why? Degree of the top winds. Top winds, always a none. But why am I going to go looking for the, did I call it an OA or an SA? I'll just write slant. Why am I going to go looking for the slant? The top is winning by 1. Anytime the top, maybe a good note to write down. Anytime the top wins by 1, got to go looking for a slant. And we just talked about how to look for a slant. Didn't we say you had to do division? This is part of finding the asymptotes. Vertical asymptote, there he is. Horizontal, none. Slant, got to divide. X goes into x squared x time. X, oh, nope, minus 1 is going to be down here. It's not an x term. What was I thinking? One quick subtraction. Sorry, x squared. I distribute that subtraction. I'm not making any mistakes today. And 2 minus a negative 1 is 3. But for slant asymptotes, do I worry about the remainder? And the answer is no. So therefore, my slant asymptote is just going to be y equals x. So I have my vertical, horizontal, slant. Talked about the domain. Symmetry. Symmetry. What are the different types of symmetry? Odd or even, or neither. Odd or even or neither. Origin, y-axis, technically or x-axis, but it's a function, so not x-axis. Johan, I'm sorry, what's up, bud?
I just forgot, how do you find the horizontal asymptote?
Oh, degree tests. You might want to take note of that. Degree test. You look at the highest powered term, and if the top wins, always none. If the bottom wins, anybody remember? Bottom wins, 0. It's dividing, dividing, dividing. It's going to go infinitely small. And if there's a tie, ratio of the leading coefficients. And horizontal asymptotes, if there is one, are always y equals, because they're horizontal lines. Symmetry for even and odd. The easiest way I know how is plug in a negative x and ask yourself, same, opposite, or a little bit of both. If you square negative x, what's that going to become? If you square negative x, isn't it just positive x squared? Oh, hey, the top stayed the same. Oh, hey, the bottom only half flipped. Only half flipped. If the whole thing flipped, it would make everything opposite. But since it only half flipped, symmetry? It's neither. It's neither. It didn't flip the whole bottom, which couldn't flip the entire. This stayed the same. This only flipped the x, and then minus 1 stayed the same. It's a little bit of both. That's a neither. But, Robbie, if you check out those directions, I think it also asks for intercepts. The two different types of intercepts are the x-intercepts when y is 0, y-intercepts when x is 0. If I was to come back up here, I'm going to just use a different color and plug in y is 0. I have to do these separately. Hopefully you guys know, at least by now, what I'm always going to do with division. I'm going to multiply. But when we multiply by 0, what happens, guys? It equals 0. So for my x-intercept, when y is 0, I end up with 0 equals x squared plus 2. Why am I going to put a slash and say none? To solve, you would have a square root of a negative, which is imaginary. That won't be on any graph. But that was for the x-intercept. What do we do for y-intercepts? Yeah, we keep the y. We set x equal to 0. 0 squared plus 2 over 0 minus 1. Well, that's just 2 over negative 1, which is negative 2. How do I put all of this together in a graph? Carefully is the right answer to that one. This one's a little awkward because there's not a lot of information, but we do have some. I have a point. My point's going to be 0, negative 2. That's my little y-intercept down there. I have a vertical asymptote at 1. I have an oblique asymptote. That's x equals 1. That's my point, 0, negative 2. Oblique asymptote at y equals x, which means going from 0, 0 to 1, 1. And there is other analysis that we could do. For instance, you could plug in 2 and try to get a point. Plug in 3, try to get a point. You can make a little table with negative infinity to 1 and 1 to infinity. You could do some test points on either side. But the long story short, if this guy's here and can't go crossing up through all of that and has to go to an asymptote, I bet he's going down, and I bet he's going over. He has to go towards both. And if you just plug in one little point, like, I don't know, maybe plugging in 2 as an x to get out a y. 2 squared is 4, 4 plus 2 is 6, 6 over 2 minus 1 is 5. 2 is going to go up 1, 2, 3, 4, 5. Maybe I can kind of follow that one also. Has to go towards one asymptote, has to go towards the other. This is actually technically a sign chart. But you guys also could just make a table and make, I think what they would say is a few extra points, and I had you guys pick points in every interval to give yourselves some ideas. The book would call it plotting additional solution points. Okay. Robbie, I know you also asked for number 17. I'm going to do that one fast, not the entire thing. The only reason I'm doing it is you might want one with a colored pen or a highlighter. Say something like this might show up on a long answer of the final. I'm not saying it will, but it might. Because there was an awful lot to keep track of on this one. You had key numbers. It's a good long answer problem. It kind of sucks as a multiple choice. It could be either one. You had key numbers and you had to test. There were 2 key points. To do key numbers, you had to move everything to one side. Now, you guys are honors. I'm not right this second going to teach you how to factor, but if you need to come in, I've been talking to HPrecalc about it for a couple days. I think it's even been on their video a little bit. Because sadly, you would need to factor this guy. Ultimately, when you do factor for the key numbers, you end up with a 2x and an x. You end up with a 4 and a 3 and a positive 8 and a negative 3x to make positive 5. Your key numbers end up being x equals 3 halves and negative 4. We use those key numbers in a table. Going from negative infinity to negative 4, from negative 4 to 3 halves, and from 3 halves to infinity. We pick a test value and we ask ourselves, true or false? I don't know, I see a negative 5, maybe like 0 or 1, and then maybe like 2 or 3. Remember, we can pick any test value, it just has to be in the interval. If you want, you could also make a little baby number line. And you could mark your points, negative 4 and 3 halves. That's where I get my interval, negative infinity, negative 4, 3 halves, infinity. But what we're doing is we're plugging back in and asking ourselves, true or false? Does a number in here, like negative 5, does it work or does it not? If it doesn't, forget it. It's not part of the answer. And if it does, now, I'm going to plug in here because this is a lot easier in my head. Negative 10 minus 3 is a negative number. Negative 5 plus 4 is a negative. A negative 10 is a negative is a positive. That's true. He's part of my answer. 0 ends up with a negative. That's false. That's not greater than 0. 2, if I plug in, ends up with a positive. That's going to be true. Part of my answer. The last thing is that we have to ask ourselves, do I open the intervals or do I close them? So for right now, I'm just going to put the negative 4. Put the 3 halves. We need to look at the inequality. The inequality to ask ourselves whether we close it or whether we open it. Somehow that's part of our solution, that's part of our solution, but open or closed here, what would you guys say based on this guy? Open, right? So what grouping symbol do I use, parenthesis or bracket? For open, open-ended, sadly, are parentheses. That's a good multi-step possible long answer problem. All right, kiddos, I am going to go ahead to chapter 3. However, I know some of you guys are like, wait, we really want to see our, okay, you've at least let me focus on, how many sections are in chapter 3? 4? 5? I think it's 5. You've let me at least focus on some of the review questions. I'm going to come back and go over at least 1 or 2 of chapter 3 review, but let's get our chapter 5 tests out. Tomorrow is our going over chapter 4 and 5. And so if you guys have questions, you can let me know. Now hold on corrections, guys, do you think I want you to correct formula? There's no point. I'm not giving you points back on formulas. You knew you had to have them memorized. It is what it is. What's done is done. But on the problems, I can give you some points back on the problems. Okay? All right, alphabetical order. Lacey, there you go. Angie, come on down. Robbie, come on down. Wyatt, you'll get yours tomorrow, bud, when I get your test, okay? Angie, here you go. Just come close. Gavin. Jason. Aiden. Austin. Kim. Highest possible was a 108. We had 2 people get that. Kyle. Johan. Sam. Adam. Kathleen. Oh, sorry. I'm just going close. Tony. We also had a 106, though. Jaden. Vico. We had some other A's besides that, too, but we did have 2 108s and 1 106. P.S. If you want correction help, ask maybe Kim or Tony or Kathleen. Anyway, so you guys have your chapter 5 test back. But for the last 4 minutes of class, I'm available on chapter 3 questions. So if you can tear yourselves away from those tests, we're going to talk about those tomorrow. Real quick, each multiple choice was worth 6 points. Each T-proof was worth 8 points. There were like 4 different check marks, 4 different legal, including like writing the first step, that was worth 2 points in the T. And then your formulas were just 1 point each out of 20. Wait, 20? No. There were like 24, 23 different ones on there. Yeah, but did you guys see a couple tangent ones that shouldn't have been? I didn't let them count against you. So I made the tangent ones as well as I think one of the cosine ones be extra credit, which is why you see 23 minus, but it's only out of 20. It'll just be bonus on that formula quiz. Welcome. Chapter 3 review. Anything, guys? Exponential logs. Chapter 3 review, exponential logs. P.S. Khan Academy has a great unit on exponential logarithmic functions. Checked it out last night for a pre-cal kid, sent her a link. Patrick JMT does a 9-minute exponential log basic review. He's the guy with the whiteboard who has YouTube tutorials. I'm offering to answer questions, but there are plenty of things online to show you the basics. Thank you. This is a chapter test. I'm still waiting, though. Anything? Kyle, Robbie. Number 2, Kyle. Okay, let's start with 2 and 11. That should get us to the end of class. Number 2. Oh, Robbie, this one just means plug in calculator. Because it says evaluate with decimals. Any answer with a decimal would be a calculator. So you just use the caret button. 4 with the caret and then 3 pi over 2. Yeah, you wouldn't have needed or been able to do that without a calculator. Number 11, though, is a great problem. Actually, I like all of them. I like 9, 10, 11, all the ones down in the 20s, because they are a solve the equation problem, but the only way to solve it is to know how to work with ln. Wait, are we graphing it? Oh, I thought we were solving it. Okay. Hey, domain problem. Doesn't the argument of a log have to be greater than 0? So x has to be greater than -6, or if you're practicing your interval notation, open -6 to infinity. It also says intercepts. Intercepts would be when y equals 0. That would be the 0 of the function. Oh, hey, now we'll have to use our knowledge of ln, because how do we get x by itself? Well, first, don't we have to subtract the 1? But how do we get to an x if there's an ln trapping it? What's the inverse of ln? Good. So then I end up with x plus 6 is equal to e to the negative 1. Negative powers, what do those look like? Isn't that a 1 over? Negative powers, remember, plop it in the denominator. I'm going to subtract 6, subtract 6. It's not a pretty answer, but technically it's right. The x-intercept is going to be at, negative 6 plus 1 over e. This is a good problem in making you deal with ln's and e's. I think some of you didn't get to chapter 3 very good last night, so maybe we'll pick up there tomorrow real quick, cover 1 or 2 questions before going to chapter 4, which is basics of unit circle. You guys did pretty well on that test. Chapter 5. Then we'll get to chapter 5. All right, cool kids? Get out of here. Let Wyatt finish out talking to him. Tomorrow by the end of the day. So you have today class, tomorrow class, tonight, tomorrow after school.
And do we correct the formula portion?
Oh, you didn't hear me? No.
No.
No, just problem. You all right? Good to see you guys. Glad you're back.
I find this really funny.
Sorry, pause.